Hello, so my name is Ivan Ziriano, and I'm going to present the paper entitled Seamless Integration of RESTful Web Service with the Web of Things. This work is a conjoint with several colleagues of mine. Between them are Lorenzo Villi, Federico Montoni, Cristiana Guzzi, Sebastian Caibes, and Marco Di Felice. Also, this paper was the software produced in this work was certified as an artifact by Percon as well. So the IoT field is growing over the last few years, right? So we have a lot of new devices being added to the network. However, this new breed of devices is generating unprecedented lack of interoperability because each of the new solutions introduce new interface, new protocols, new data structures, new platforms, and that really hinders the adoption of IoT in large scale because in order to produce end-to-end system, you need to develop integrations, you need to develop adapters, and that takes time and costs money. So one of the standards that offers a potential solution to that problem is the Web of Things. Is a standard that seeks to counter the heterogeneity in the IoT field, in the Internet of Things, by extending the already known web standards, web technology to the IoT environment. Uh, they offer a common interface between all actors in an IoT system, and also they decouple the application logic from the underlying protocol stack. So that's quite important because you can consume the web thing using several different protocols. So just a few words about web of things, as not everybody knows. A web thing is a physical or virtual entity, and the metadata and interface of that thing is described by a human and machine readable document called thing description. Is a JSON LD document that describes a web thing that can be a sensor or a virtual entity and so on. This thing description has basically the things affordances, the protocol binaries, its security configurations, and its data schemes. Its affordance is how you it's how you can interact with a given web thing. So what are the properties that you can query, the actions that you can invoke, and the events that you can subscribe to. And the protocol binaries is how, in which protocol you can consume those affordances. So you can use HTTP, HTTPS, MTTP, CoAP, and so on. That's why it decouples the application logic from the network stack using protocol, given that it's implemented as a protocol binary. Usually IoT devices in IoT applications, they interact with web service. It can be as like an IoT platform or other third-party application. And currently, the Web of Things doesn't have a solution or a guideline to convert REST interface to the Web of Things interface or to a thing description. So the current state that you need to develop a custom solution to interface a web thing with a REST API web interface. This, of course, increases the complexity and the heterogeneity of the system, since you have multiple interface that are quite different one of the other, and also because you need to know the specifications of the details of the web service interface that you are using. Also, it's only possible to utilize a RESTful web service API using HTTP or HTTPS. So the application logic is tied to the networking stack. So if you have a device or solution that is not that doesn't talk web HTTP, we are going to have a problem. So what we propose? We propose a technique that seamlessly integrate RESTful web service into the Web of Things ecosystem. So why this is important? What is the contribution of that? So that we provide a uniform interface of all actors encompassed in an IoT-based system. So no matter if your communication or interface with an IoT device or a complex web application, the interface is going to be exactly the same as in description. Also, we decouple the RESTful interface from underlying protocols. So you can query our RESTful interface web service in different protocols, not only HTTP. And of course, we enable the seamless communication of web things and web of things based applications with web service. So our method consisted of translating a documentation of an API of a RESTful interface called OpenAPI specification to a theme description and instantiate a proxy of that web service, a web theme proxy of the web service, so web things can interact with that proxy. I will give more details in the following slides. So we have some other works that in the interoperability field, specifically trying to make interoperability between web service and device, specifically using Web of Things. So we have Data Spy, that is a federated platform that bridges IoT interoperability gaps and enables the creation of ecosystem of heterogeneous IoT platforms in the manufacturing domain. We have several other efforts that combine the Web of Things with RESTful interface, but the solutions are specific to specific web things and specific RESTful interfaces. And also the last one is a previous worker of us that first introduced a method of translated open API specifications. That's a way to describe APIs, RESTful interface, to a web thing interface. However, that was specific to Arrowhead frameworks, specific for specific to a project. So for our architecture design for our method, we had two major guidelines. We don't want to connect two platforms to services or two class of service. We want a technique that was able to connect significant number of applications. And also we want to do that without making significant change in the system. So we know that interoperability cannot cost users to change their application. We want to do in a way that these changes were not necessary. So what we did was a method to translate open API specification. As I say, it's a way to describe APIs, a very common way, highly adopted in the industry and in the academia as well. Those are like Swagger interface, our open API specifications into a web thing descriptions. And then using that thing description, we can instantiate a web thing that acts as a proxy of the real application, and through that proxy, web things, sensors, and so on can communicate with that web service. So we have some issues on doing that. There is no exact match between HTTP methods and Web of Things affordance, but we have some similarities. So as you can see in that table, for endpoints that had the method get, we translate to readable or writable properties. For HTTP method post, there was web thing as an action. Put we translate as a writable property. fetch as well as rightful property, and delete as an action. Um, okay, so we utilize that guideline to translate those, and I will give a quick example. So in the left-hand side, you have an open API specification. So you have the version, you have some metadata, the title of the API, its description. Also, you have the server, so where it's running. This is important because when we instantiate the proxy of the real service, we need to know where the real service is to query it. And then we have the paths, and this is the actual endpoint. So we have here only in this example, only one endpoint that's the status and is the method get. And we translate it, as you can see here, as a property called get status. So we translate using the operation name, so get, post, and so on, and the name of the endpoint. Also, you can see that title, its description is all incorporated in the web theme description. So we don't lose much of the data, the metadata. Okay, so we also developed an application capable of doing that translation, of implementing our method that was doing. Our application is called C3PO. So C3PO from the Star Wars movie, it's a drone that assists in translation. He's fluent in over 6 million forms of communication. So our application called C3PO, it's actually it's because of converting of open API specifications to WebAuthn objects. As you can see, it's kind of funny, but the idea is that is a translation. It translates open API specification for RESTful service into WebAuthn Streets API. Okay, so this software that was certified as an artifact, and there is a 2-page paper in the PERCON proceedings about it as well. It's open source, of course. So it has, of course, a Swagger interface as well. So this is an interface of the service. You interact with it only through its API. This is the raw interface, and here is the graphical one. And how it works. So very simple description of its service interactions. If you query this endpoint, send a post request to this endpoint containing an URL that has an open API specification, what is going to do? What CTPO is going to do? First, a user performs here a request in the C3PO API, given the body of the request, a URL where there is an open API specification. C3PO is going to fetch that specification from that service, is going to translate that open API specification through to a thing description, and instantiate a WebAuthn proxy of that, and then WebAuthn mesh applications, web things, and so on can utilize this WebAuthn proxy to use this WebAuthn proxy to consume or to interact with the real web service here. So that's the idea. CTPO spawns these proxies. It also has a simple web interface, doesn't have all the features of the full service, all the features of the service through its API, but it has this playground. It's in this URL, and I invite all of you to go and test it. It just do a syntactic translation of open API specifications to web things, but it's quite interesting. So instantiating a proxy adds latency to the system, and we wanted to evaluate that added latency, because we cannot add latency that would impede or would make the system too slow, right? So we made experiments querying direct the web service that we wanted, and querying through the WebThing proxy, and we measure the latency between the two of them. We have workloads of 3 different workloads, 25 requests per second, 50 requests per second, and 100 requests per second, and we reply each experiment 30 times. So this was the scenario of the experiments. We developed a software to generate the workload called Professor. So directly querying scenario A, scenario B querying to the proxy. We utilize all the requests, get, post, delete, put, and patch. And those requests follow a Poisson distribution. This generic web service didn't perform any computation at all. It just replies. So we just are measuring here the web proxy, the WebThing proxy overhead. So those are the results. Here we can see that the system scales very well. There's no much difference in latency in all of them. And although the difference seems meaningful, it's only 0.5 milliseconds for all the systems, almost all the systems. That added latency in all the scenarios is negligible, doesn't matter. Of course, the system presents a very low response time because the web service didn't do any computation at all, just reply. Usually it is going to query from database, do some sort of computation. All the machines were in a connect to a high-speed connection locally, and all the servers were implement Node.js, and it's an engine node to be good in and out network operation. So the performance is going to be good as well. So finally, we model a use case using structured health monitoring sensors that are sending data that they monitor the vibration of a bridge to a Web of Things mashup application that's responsible to monitor the bridge or a structured health monitoring scenario. And it used the C3PO translation to query actually a service that monitors seismic data. So this is important for the mesh application to know if a vibration in the bridge was a local phenomenon or if there was actually a seismic event nearby. So it wasn't local, it was due to an earthquake, a minor earthquake or something like that. So that's it's a use case that C3PO enables. Okay, finally, just some conclusions. We propose, implement, and evaluate a solution that bridges RESTful web service into the Web of Things ecosystem. Through that, we could decouple the application logic of the RESTful web service from the underlying protocol stack. And as future work, we would like to expand the performance analysis to quantify the impact of consuming a real service through the WebThing proxy that do some kind of computation, and also to implement the translation of all other API description methods other than the OpenAPI specification implemented by Swagger. So that's all. Thank you for listening. I am open to questions.